Oh, hello everyone. I can see that people are still having a coffee out there. So hopefully you can rush and come in so that we don't lose much time with this presentation. Okay, so we start. My name is Leonardo Losoviz. As they were mentioning, I'm from Argentina, but I live in KL. And I came to talk about APIs. The presentation slides are already online, so you can actually check it out, slides.com/leoloso/component-based API. You can actually take a picture of that if you want to check it out later. I will give quite some stuff. 25 minutes is kind of hard to fit everything in. So if you want to find out more later, I mean, maybe we can go in more detail. And my Twitter handle is Losoviz, same as my surname, okay? So we start. So if we're talking about APIs, we must talk about the current hot stuff, which is what? GraphQL, right? So GraphQL is increasingly popular. This is the stats from the state of JavaScript from last year, that it says that 20% of people who have used it, they have liked it, so they want to actually use it again. And 62% they have heard of it and would like to learn. So I mean, this is certainly gaining ground, and we can expect GraphQL to be the new normal. I think maybe it's time out for REST. There are a lot of REST APIs which are still out there, of course, but if you have to start a new project, quite likely you might actually want to do it with GraphQL. Oh, that's the situation right now. So why is it so? The one characteristic from GraphQL that everyone talks about is that you can actually get exactly the data that you need to feed your layouts, your components. So say that you have this layout, okay? So this is like a widget with a feature director we have up there, showing a couple of films, and each film showing some of its actors. So the way that you actually fetch the data through, okay, well, actually, you need to get data. So in the case of the director, we need to get the name, the country, and the avatar. Then for each of the films, we have the thumbnail and the title. And then for the actors, we have the avatar and the name. So GraphQL is very straightforward. You can define a schema, and then you define a query that lets you get the data as you need it. And what you actually get from this is a response with the data in the structure as you need it. So this is actually quite cool, right? You get exactly what you need. So this is an improvement over REST and why it's taking over from REST. And this plays very nicely with components. So if you're actually guys coding with React and Vue.js, I guess that's the situation, you will actually love GraphQL because it goes one-to-one with the concept of components. So in this situation, we have an outer component called feature director, which has a film. It iterates over the list of films, and each film component has calls an actor component, okay? And if you actually pay attention to this, it's exactly the same structure. So it's very practical for this. So far so good. GraphQL is awesome, but it is not perfect, unlikely. So it comes with a few limitations or trade-offs, we can actually say. So one of the trade-offs is that it is not cacheable on the back end. You can still cache the query, but it has to be on the client side. And there's a penalty for that because you're adding code to the front end. You have to parse the JavaScript, you have to execute the JavaScript, so it is not ideal, okay? Another problem is that this is susceptible to denial of service attacks, because now you're giving a lot of power to the client to fetch whatever data they want. So if any evil person, they want to actually take your database down, they can actually execute a very complex query that maybe your server will take 1 second to process. It doesn't seem so much, but actually doing that for many, many thousands of queries can actually take the database down and your service down. So once again, this can be mitigated. There are strategies for dealing with these DOS attacks, but it's also adding complexity to the application. Now you have to actually think about the complexity of the query. You have to think about the nested, the depth of the query. You can limit that. You can actually think about timeout. So once again, this is not ideal. So let me present you a project that I've been working on that it's called the Component-Based API. And before anything I need to say, it's a work in progress, and it will be released in a few months. So I'm kind of sorry about this. I wanted to finish it for JSConf, be here saying, okay, we're releasing it today. And you know, I mean, planning time, management of time is one of the most complex things in software development. So it hasn't happened. it has been like 2 months away from being ready for like 6 months now, and it's still a few months away. So yeah, I'm sorry about this. But everything that I'm going to show you now is working. All the fundamentals have been implemented, and I also have it running on a couple of production sites. So whatever you will actually see here is pretty much there, okay? I'm not bluffing. Everything that I will show is actually working. I will try to do this following the example by GraphQL of having an open specification, so then you can implement it for different technologies and how different systems interact with each other independently of their underlying implementation. That's pretty cool, what they did. And finally, it's a recognition that not everything is bad about REST. So GraphQL is actually taking over from REST, not because REST is bad. Both have advantages and disadvantages. And actually, they may even complement each other in the sense that REST has advantages that GraphQL does not have, and the other way around. So I was actually thinking, this actually is pretty cool from REST. No need to discard that. And what I actually try to do is to get the best from both approaches, which is what I'm going to show you now. So mostly concerning fetching data. Basically, the good thing about GraphQL is that it allows you to fetch the data that you need, exactly that, and that was the big problem with REST. So I actually took this. It allows you to fetch exactly the data that you need, like GraphQL, but it has an interface like REST. So if in GraphQL you have a query of this type, you have a feature director with a few properties, then a film with a few properties, and then an actor, the way that I translate this through the URL is, first I get the properties for the director, and I pass it through a fields parameter on the URL. Then I get the property for the film, and I also pass it through the fields parameter in a kind of dot notation. So it's now films.title, and then a pipe thumbnail to say this property or that property, or actually this property and that property. And finally, once again, for the actors, starting from the root, films.actors.name pipe avatar. So having this syntax, I can actually query the service from the URL. So we have solved the cacheability issue, because now my URL is my identifier, and I can actually cache this in the backend. So that's the first thing that is actually solved, a combination from REST and GraphQL. Now, concerning the shape of the data that we're actually fetching, so in GraphQL, what you have is that the shape of the data mirrors one-to-one the query, right? You say, give me a feature director, and then the feature director has the film, and the film has an actor, and you're actually returning exactly that same shape. But I decide to use the structure as the data has been defined on the database, assuming that it's an SQL database. Maybe this doesn't make much sense with a NoSQL database, but if you have an SQL database that you have like tables, and you're thinking of rows and columns, okay, and then you have relationships among the entities, that you have an ID pointing to an object on another table. So that was my model on which I actually implemented this. So once again, this is GraphQL. This is how you get the response. And what we have in this other paradigm is databases, and then you have this, you could call it the table, sort of. I call it people, with the ID of the entity, okay? Now it has the name, the country, avatar, and films. And these films, instead of being nested to get the entity of the film, it has a reference to the ID entity. So then we go to the films down here, and here we have the entity with that ID. So this one has its own property, style, thumbnail, and then it has the property actors, which is an ID pointing to the actor entity, back again on people. So it's, you know, as you can see, this is actually replicating sort of the structure of the database as you have it on the back end, like bringing it to the front end. This solves the denial of service attacks. Now, why is that? I will actually have a different query to explain better. This is a tiny bit exaggerated. I don't think I will actually have a query like this, but it makes the point. Imagine that you have this query, that you're querying for posts, and all the posts, you bring the title and the author. Then the author, you have the name and followers. The followers have the name and the recommended post, which has a title, author, whatever, okay? So if you actually pay attention to this, you're giving different names to the same two entities, which are the post and the users, okay? So if you actually think about this in terms of GraphQL, you have a nested relationship among all of the entities, and you have a query executing after a query executing after a query executing after a query, right? So everything is compounded. And I read in a paper that the complexity of this, I don't know if it is right or not because I didn't see any validation of the paper. I can share the URL with you. But it says that the complexity is exponential to fetch the data and is polynomial to find out the complexity of the query. So that if it goes over the threshold of your security limitations, you cannot execute it. But at least it takes polynomial time. But if you're thinking about this structure, in terms of database that you have in the SQL database, this is simply two tables, like post and users with relationships among them, and you have actually made it flat now. And because it's flat, and I know that the entity that I will have is the same that I already have loaded in advance, I just get the query, I get the IDs from the further executions, and then I compile everything together. The time complexity is linear. So because it's linear, you can actually have 200 nested, like the relationship among the entities can be like 200 levels down, okay? And this still performs well. I don't know if that's the case with GraphQL. I don't think that you will have a use case to have like 200 levels deep down. But if you ever had to, this performs better because it's flat. So I'll show you a tiny bit more about the API response, what we actually get. So the idea is that you have the data that comes back. How do you use the data, right? I mean, how do I know which is the data that I need to show in my component? So we said that we have an outer component called feature director, getting its fields, name, country, and avatar. Then you have an inner component, the film, and then you have an inner component, the actor, right? So the way that I actually solve that problem is that you have the ID of the entity that is querying for the data. In this case, the one who is querying for the data is the feature director. It's saying, I need the feature director, okay? And then the subcomponents will be asking for properties from this retrieved entity. So this guy, he says here, the feature director, the result is entity with ID 1, okay? From which database or which database table it appears under the key ID, which is people. So when you go to people here, it says people, entity with ID 1, name, country, avatar, and then films. And then it gives me the ID of the films from this guy. So entities 1 and 2. Where do I retrieve this data from? Here it says, from the key under films, which is called films also. So now we come to films, and it gives me the entity, okay, title, thumbnail, actors, and actors, it gives me the actors with IDs 2 and 3. Once again, where do I get them from? From films.actors, and it says you have to get these from the database or table called people, okay? So now in people 2 and 3, we have these entities. And you can see that the data that I'm actually retrieving from each is exactly what they need. So this number 1 is George Lucas, is a director. I need to display the avatar from him and the country, okay? Ewan McGregor, he's only an actor. So I'm not showing the country from him, and it doesn't even display this, okay? So it doesn't bring it. So it's pretty much like GraphQL, but the data is arranged on a different structure. What is the cool thing about this? One thing is that the data is normalized. So you can see on the example, we have the same actor twice, Natalie Portman. So in GraphQL, you actually bring this data twice. Here, you bring it only once. Then there's a unique database containing all the data in the client. So you can actually merge all of these because now it's flat. You don't have like nested levels with renaming of the same entity. Now you know a post is a post, a user is a user. It's flat. You can actually merge it when you bring it from your call to the API. You merge it on the client, and you have a cache. So if you know that you will need to fetch this data later on, and you already have retrieved it, you have it there. You don't even need to make that call. So this is awesome for performance, because the most performing application is the one that does not need to make that HTTP call. If it is redundant, don't make it, and this makes it possible. And finally, another cool property is that because the database is shared among all of the components, if one component is fetching data, okay, And this data has been updated in the time in between, and another component also was using that same data. Then both components can be re-rendered. You can observe on the database, basically. So instead of building constantly an object on the fly and then observe this object, you can actually have an idea of being constantly observing the database, and the layout can react to the data inside the database. This is not implemented, by the way, but the architecture supports this, and that's hopefully one of the upcoming things that I will implement soon. So concerning the API response, I don't have enough time, so I cannot show it to you. But if you are going to check out the presentation later on, you can click on these two links, and this is deployed on a production server, so you can actually see it working already. So having this, everything that comes that I will actually explain in the next slides is working. So let's see how this works. So the important thing here, and I'm sorry about this, is that the components are implemented partly in the front end and partly in the back end. So I know that you're not, that you don't trust backend developers. Yeah, and this is something that, believe me, makes sense, and I will try to convince you so that maybe you can have a tiny bit more of esteem for us. But the thing about this is that this is not backend or front end. The component actually lives between the backend and the front end, and it implements part of its responsibilities where it makes most sense. So what I'm talking about here is the following. I have delineated 4 layers, okay, that make it up as a progressively enhanced service from API to application. On the very first layer, you have the data layer, okay? So this is basically your API. You define what data the component needs. And having that alone, you already have the API. You can actually stop it there, okay? But you can also continue. You can, on top of the data layer, you can add a configuration layer, okay? On the back end. So I'm talking about defining classes and styles and the strings that you need to display in your view, that you actually set it up on the back end. Then we go to the front end, the view layer is on the front end, and of course reactivity also will happen on the front end. So what basically I'm saying with all of this is that the application, your own application that you have for your own site, can be modeled as an extension of your API. So that you have to provide an API for your clients to retrieve your data. Well, your application can actually continue from there and demonstrate the API. The application becomes the API. And the other thing is that the example that I showed you about querying specific fields through the URL, which is basically the GraphQL-like functionality, is simply a specific use case of this architecture. Because what I do is to basically, on runtime, create the hierarchy of components that I need to match those fields, and I give it back to you. So that's just one use case, and what you can actually do with this is actually much more. So I found that actually pretty cool. How does this work? So on the backend, we have component hierarchy, which is how a component relates to each other, like I own, or like I'm wrapping this component and that component is wrapping that component. You have props, you have data fields, and you have the configuration. So I have coded this in PHP. This is PHP code. So you have functions, get some modules, which first defines the hierarchy of how components relate to each other. Then you have init props. And init props is very interesting. I mean, it receives a module and the object props to initialize. A component can set properties for itself, of course, and also for its children component, like all the way down, right? And every ancestor has higher priority over its children. So the topmost component at the very top can, for instance, set properties, overriding all the properties from its children, okay? That's one thing. But second thing, that this is on the back end. So it's also very easy to set properties horizontally, not just vertically. So you can actually, in just one line of code, say, all these many components inject this property. And it just works. And you don't need to deploy any JavaScript file, you know, when you change one string, you know, like, I mean, one description or one class name, okay? You just change it on the back end and it's already live. No need to deploy anything, no need for Webpack or anything. Then you have the data fields. I will explain this a tiny bit later, and the configuration. And this is how it looks on the view. I have implemented this with handlebars. So this is an example of a drop-down. And you can see basically a div, then there's a button, then there's a UL, and it iterates all of its submodules, and for each of them, like it prints an li, and it says each of the submodules render yourself. So what's so cool about this is that the component, the view in this case, is completely decoupled from its children. This dropdown doesn't know who its children is going to be. You actually settle that on the back end through configuration. So then you are really playing like Lego, like this is on steroids, because you have only one implementation of the view that you can actually add, inject everywhere. Yesterday when we had the talk by Issue, and she was mentioning about this apocalypse, right? This complexity of props, because you don't want to separate the component into another component because the functionality is kind of the same, and you don't want to duplicate code, right? You want to stick to dry, and then you end up having a monster. And she was saying, it's okay, you can repeat code, it makes sense, okay? With this architecture, there's no need for that, because this is how the component looks like in the front end, okay? It's extremely decoupled from all of its children. So then there's no apocalypse. It just cannot happen. So every component creates its context on the backend, and it receives its context on the front end, and only its context. On the view, you just don't care about having to iterate the data. You get it. The view doesn't care about its subcomponents, and props can be set vertically and horizontally. So this is the component architecture. Let's say that we actually have a page, in this case, /post/lovelytango. At the very top of the page, my component is called post, and it will contain some other components, right? So in this case, I have a subcomponent called post title, one called post thumbnail, and one called post content. So this is, the way to represent this is very simple, okay, just like that. This is an oversimplification. I mean, as you can see, there's like a big widget there, and the widget contains other components, and the component contains other components. This is just to simplify, okay? It makes the case. And the way that it works on the backend is that you define the relationships among all of these components with that function. For retrieving data, each component must define what data fields it needs from the database just for itself, without including the data fields for its subcomponents. So you can think about this like fragments in GraphQL, but on steroids. Because once again, each level of the component defines, this is my data that I need, not my subcomponents. So in GraphQL, right now you have the possibility of a component getting the data also for its subcomponents. Okay, but in this case, each component at each level says, this is the data that I need at every single level. And the cool thing about this is that by having this architecture, the endpoint URL from which to fetch the data, and also the query to execute against the database can be automatically generated from the component hierarchy itself. So what does this mean? So we have this component architecture, right? So the topmost component says, I need to fetch data from this post, okay? The one corresponding to the URL. And from that moment on, all the components inside of this guy, whenever they fetch a property, it will be referencing this entity, this post. So post title will actually load property title, the post thumbnail will load property thumbnail, and post content will actually load property content. So iterating from the topmost component all the way down, you get the property from each, and you can construct the URL. So now this endpoint URL, okay, that I was showing you how you can fetch the data as you need it, like GraphQL-like sorts, I don't even need to code it anymore, because it's automatically generated from the structure of the components itself. And that's amazing. If you actually change one component and you add another component, it really works. But not only that, because now this is living on the back end, I have the possibility to also create the query. Okay? So you can also decide to execute the data immediately on the server and retrieve and return the data immediately. No need to actually have that round trip to load the client, and then the client needs to fetch the data from the server, and then the server returns the data, and then you render that. You can just return the data directly. That's an option. I'm not saying that you have to do this, but now you have the possibility. You can actually choose. So if you actually want to have like relationships among entities, this also works. When we're actually loading this post author component, he will actually change the entity from the post to the post author, okay? And from that moment on, all the subcomponents from this guy will be loading properties on this entity, on the user or author. In this case, the username loads property name, and the user avatar loads property avatar. Once again, the endpoint URL and the database query are automatically generated. How does this look on the front end? So we have the view for the outermost component, which is basically a simple few lines saying, okay, now inject this entity into the context, and then iterate over all my submodules or subcomponents, and for each of them, render yourself using this entity on your context. Okay? So when these subcomponents that receive the data, in this case the tile, it just prints itself. Okay? It has the object that has been loaded on its context, and it says, I want to show my property tile that you have specified on the backend. Okay? Property tile. But now also, because we can load configuration, we can even do something like this. We can actually say, okay, I want, instead of saying h1 straight on the view, you can actually say h1 through configuration, okay? Add a class also, and you can change this through configuration. That's pretty powerful. Wait a second. Yeah. So, and when it reaches the post author, it's the same. So this guy will actually change from the current post to the post author into the context and tell all of its subcomponents render yourself using this new entity. I had to wrap up, so I'm going to be pretty quick now with this, but I want to enumerate all the many advantages of this architecture. First one is isomorphism, which is basically the capability of running your code on the server side or on the front end. You're thinking of JavaScript. This is another approach. So on one side, the handlebar templates, they can be compiled to run as PHP. There's a wonderful library called Light and Candy that does that, and it runs like native PHP code. It's very fast also. And on the other side, the PHP configuration can be exported as a JSON file, because basically this component hierarchy is a big array of components listing all of their properties and then saying these are my subcomponents, listing their properties saying these are my subcomponents. So this is an array. You just execute JSON encode on this and you obtain a JSON. So that means that you have on one side the possibility to run this on the server and execute server-side rendering, okay? And on the other side you can export this for the front end, and you have a serverless application. It's up to you. And the code is the same, and it works on both back end and front end. Then, you can also target specific components. So, in this case, we have a post, and the post has a component called post tile. I can, through the URL, say, I want the data just for this component, and also for this other component, okay? And what you get is the equivalent of getting the data just for these two guys and nothing else. And that I find wonderful, because what this means is that the component is its own API. Imagine that you have a component that is like a infinite scroll. You reach the bottom of the page, you need to get more data. Now the component can just talk to itself, say, I need more data. So you construct the URL, the current URL, and the path to this component starting from the top, and it will only process the data for this guy. And once again, because the hierarchy is such that at the top you have one component at the very top, then the website is its own API. So there is no difference between API and website anymore. This is both an API and a website at the same time. So you can also implement single-page applications, and you can also create pattern libraries very easily, because you render a component and it gives you the visual identity. A component also knows which is CSS that it has to load and it's JavaScript files. It just does it. You don't need to code it somewhere else. Finally, you can implement COPE, which means create once, publish everywhere. So you have a single source of truth for multiple platforms, web, email, apps. So you can actually have a JS component that extends HTML, CSS component, and an HTML, CSS component that extends from your abstract component. So you can actually layer the generation of the layout. In this case, we have a website, and then you have the email. Every page on the website can be sent by email for no extra cost. So I'm finishing. Yeah, sorry. In a nutshell, advantages of this architecture. You have a client-side cache, easy to change the behavior of the application, it's isomorphic, the component on the website is its own API, implement single-page applications, easy to generate the pattern library, you can implement COPE. So in summary, from all of this, you have a lot of reduced complexity, Because if you want to do all of these other things anyway, you have to do 2, 3, 4 different technologies. Here with just one architecture, you solve everything. More output in less time with fewer resources. So, finishing. So, this is open source, of course, MIT license. The URL is github.com/leoloso/pop. Okay, so check it out. It's not ready yet. Okay, I'm a few months away from finishing. Okay, so if you cannot wait, come talk to me. There's not much documentation. There's some documentation, so you have to talk to me. Okay, but check it out. Okay, and once again, if you want to check this presentation, slides.com/leoloso/component-based API, you can click on the links and see it working. Thanks so much.